So my name is Mariana Falco. I'm from Argentina, clearly, and I'm here to present to you a work which is part of my PhD in engineering. And the main idea right now is I'm going to talk to you about a little bit of product quality within the software lifecycle. So a brief agenda of what I form or prepare for you today. So a little bit of why we do this, our method, and the main conclusions. So when we talk about quality within the software product or the software life cycle, actually all know that quality needs to be evaluated and understood at different levels of details due to the fact of the existence of different stakeholders such as project managers and developers, DevOps, quality analyzers, and others. And so it's really important that all within the team understand the level of quality. And in that case, it's super important that we have tools or yes, methods even, right, to provide or realize or put together a meaningful quality assessment in order to understand how our product is reaching this quality or trying to figure it out in an easy way with all the stakeholders in topic, right? And so within this context, considering that there are different methods or reality presented or available in the software companies or even the software area, right? For us, it was important to define a method which allow us to understand, evaluate the product quality within each iteration, right? Because clearly all of us have used or even heard about the agile methodologies. And so sprints are super part of our days and our development courses and our work, even though. So it was really important for us to define a method that in our context would be useful on every iteration. So clearly, PQM is a product quality evaluation method, which we have defined, and it has 5 steps, which the main goal of this method is to analyze, study, measure, and assess the quality level, right, of the software product within or for each iterations. The main output of this method is to produce a single value between 0 and 1 as a final outcome that represents the product quality level that we call it TOC. T-O-C. And so the important here is that this output can be understood as a multi-dimensional value, which is the result of an average or an aggregated number resulted in calculating a set of coverage per amount of quality characteristics, mostly the iOS 2.5, 0.10. So based on this, I wanted to talk to you about, to let you know about these steps. So the first step, as I said, we have 5. The first step is a product setup, where we are going to define next to the stakeholder, which can be the project manager, the quality analyzer, the QA, right, to define the amount of iteration and the acceptance criteria, which is what is the level or the quality level that it will be okay for the iteration to pass on, right? And the amount of iteration of the entire product, let's just say we have a company, the company has a product, and this product will be developing, I don't know, 3 sprints, right? 3 iterations. So for each iteration, we have to define what is our respective quality level to be accepted or not, right? So for instance, as I said, it had to be a number between 0 and 1. And so we can say, okay, for the first iteration, we gotta define an acceptance criteria of 0.70, and we can move on that, right? So to the step number 2, we are going to define or to produce a set of quality attribute requirements, which are abbreviated as QRs, right? And so first we define what are the quality characteristics, right? Which are the ones that we really wanted to learn about it and to understand how our products go and how it will be, right? Then we're going to define these quality attribute requirements, which can totally think of or thought of as a set of questions if you're already used, I don't know, maybe goal question metric, right? This will be our goal. Then we're going to define the metrics and then the acceptance criteria. So let's just imagine this as we have a spreadsheet with each column has the quality characteristics, then the goal, then the metric, then the acceptance criteria, and then the result. And that result, we're gonna fulfill it in the within the step 3, right? Because we're gonna say, okay, I don't know, for portability or availability, wherever the quality characteristic will be, or we have decided on the previous step, right? We're gonna measure and we're gonna test if that goal or that question, that metric is fulfilled or is present within the development or the architecture, right? And so we're gonna say, okay, it pass or not pass. In that case, it will be a 0 if it's not there, or if it's not present, or it's not fulfilled based on the acceptance criteria, and a 1 if it is present or accepted. With that, we apply that methodology for all of the quality characteristics and quality attribute requirements. And so we're going to collect the results on the next steps, and we're going to calculate a set of coverage, a coverage per year, each quality characteristics. And then we're going to calculate or obtain actually a quality coverage in total. So for each iteration. And so we're going to synthesize those results, and we're going to compare, or on next step 5, whether this product or this quality level is next to or surpass the expected quality level defined on the step 1, right? Those acceptance criteria that I mentioned earlier. So we're going to make a decision, and we're going to say, okay, if this value is okay, then we can move on to the following iteration. Clearly, this is in an iterative way. Sorry, it doesn't understand like that on the graph. And if the product doesn't achieve or doesn't reach or didn't reach that goal of expected value, then we're gonna make a new measurement, come back, or we can define even or redefine some QR in order to make it more feasible, more understandable for each QA. And so we're gonna move on this product or this analysis through each iteration in order to reach a total amount of quality per iteration and in the product. So maybe it's easier if I show you a little bit of an application, right? Following an illustrative example, so we can visualize a little bit more what I have said earlier. So let's just say that I use a second iteration of an app, which this app is called Haircare, and the main goal of this app is to ensure that the recovery of cardiac patients, right, outside the hospital. And And so it has monitors, it has sensors, it has a mobile app for the patients where they can uphold measurements and move on and continue their, like a fit up, something like that, but mostly for cardiac patients. And the web app, sorry, will have, or will let the doctor to move on or to understand the monitoring of their patients, right? And so the first step within the product, sorry, the method will have, like what I said, the amount of iterations and the acceptance criteria. So let's just say we have 3 iterations for this application. The first iteration had defined 0.70, the second the same, and the third iteration, because it's the final, and we had the stakeholders decided that it was extremely important to have a better quality or a bigger value, right, of quality. It's 0.8. So considering that we have 3 with those acceptance criteria, let's just go to the second step. So as you can see, the table or the graph is the set of quality characteristics and sub-characteristics within the iOS 25010. And so let's just have the functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. And so it is important, of course, you can use all, right? And you can put it together in order to feasible, understand, and measure during the application of the method. So based on that, then you're going to define a set of quality attribute requirements, right? As I said, we generated through the goal question metric approach, and clearly can be sort of as questions. As you can see, I had an example, like we defined first the quality characteristics. In this case, we got availability. The QR, the quality attribute requirement in this case, can be if the recovery time objective can be applied to the operating system. And then we define the metric and the acceptance criteria. So amount of minutes, and there should be less than 90 minutes. And so the measurement itself would be, as I said, to analyze the existence or the viability of this goal or this question within the applications. As it passes, we have 1 as a result. And so let's just build this table as I showed you earlier, or as I tried to explain to you earlier, about how to properly collect those results. As I said, we defined a set of a formula, right? I didn't include it in here because I thought it would be not useful maybe to show our idea, but instead of, I decided to include this illustrative example. So for this iteration of the app, we selected those characteristics, clearly all of them, and let's just build together the results. So in first place, based on this, let's just have in here the second column that just appeared. It says, or it shows really the amounts of quality attribute requirements per each quality characteristics. And so, as you can see, we had a lot of topics or questions to analyze, right? And so based on that, we have analyzed whether they passed or not. This is the test, the results, as I said earlier. And so this is the difference between them from the possibility of the total amount on the first column, sorry, the second column. The third column shows what those are the past one. Then we calculated and obtained coverage, right, from each quality characteristic. Later, we calculate or we define the expected coverage, which is based on the total amount of quality characteristics, not each of them, instead of the total amount as the iteration, right? Which is our main goal, to calculate this quality level for the iteration or the iteration. So based on this, our total expected coverage have to be 1, right? Because our total quality or our quality level will be between 0 and 1. And so the overall coverage is like this TOC value, total obtained coverage, is 9.0. So these values, as you can see, is one value that is telling us the level of quality, and is calculated through a set of coverage, total coverage and particular coverage of quality for each quality characteristics. So the following step is to compute, to calculate, to collect this value and to make the decision and control, right? So as I said earlier, the first iteration gave us a value of 0.775 and the acceptance criteria was 0.7. And this second iteration, as I show you, we have defined an acceptance criteria of 0.7, and we obtain a total obtained coverage, or a TOC value of 9.9. So we can move on to the next iteration, which is our step now 5.2, where we have to make a decision and to control what is the quality level achieved, right? So in this case, we move on to the third iteration. If this value was lower than our acceptance criteria, we have to redo the measuring until it was fulfilled to continue. So clearly, based on our application and what we have defined, we try to define or to establish a set of proper metrics to monitor. And I say proper when I say, I really mean is maybe an easy way to define a set of metrics to monitor software quality and a software project, right? And through PQM, we have the availability to assess this quality level by achieving this single value and multi-dimensional value between 0 and 1. And clearly, we believe that our main contribution here is that a project manager, a quality leader, can understand easily and quickly whether the project has quality problems, or there are, I don't know, technical debt or waste in some way, in order to move on and take measure rapidly. Our future work is that we are currently developing a web version of this method, not this method in particular, but a generalized idea of this method in order to be able to be applied to several products or dimensions in this industry, instead of only to software product. So thank you very much. I hope I was clear as much as possible. And again, thank you for your time.